Hello everyone, welcome to 30 Days Data Science Project Series Day 2. In this video, we are going to discuss machine learning project. So let's first of all try to understand what all those things that we are going to cover in this particular project series. So first of all that we can start with the problem statement understanding, and based upon the problem statement we can understand our complete data set. After understanding a problem statement and the data set, then we can perform some of the EDA operation, and based upon the EDA operation we can find out some of the insights from our data set. After finding our insights from our data set, then we can perform a data preprocessing and complete feature engineering steps, where in a feature engineering steps that we can handle a missing value, we can handle the outliers, we can handle the imbalance data, we can convert our complete categorical data into the numerical format. So these are the complete feature engineering steps that we are going to perform. After performing a complete data preprocessing and the feature engineering steps, then we can apply a machine learning algorithms. Again, for the machine learning algorithms wise, we are going to apply a multiple machine learning algorithms, and based upon those algorithms that we can build our first of all model, and from those model we can select a final model so that the same model we can use to build a complete web application. Okay, so now let's start with the problem statement understanding first of all. So the problem statement we have in this particular project, we will work with the advertisement data of a marketing agency to develop a machine learning algorithm that predicts if a particular users will click on advertisement or not. So let's try to understand with one of the example. We all are using some of the social media platform like Facebook or the Instagram or the YouTube. So whenever we open any types of the video over the YouTube, in between the video that we are getting a multiple types of the ad. We are getting the images ad, we are getting the skip ad, and we are getting the non-skippable ad, right? So the different types of the ads that we are getting. So as a user that we are going to click on those particular ads or not. So this is the main problem statement that we have. Okay, whatever the ads that we are getting over the YouTube or over the Instagram or over the Facebook, any social media platform, as a user that we are going to click on those particular ads or not. So this is a mainly classification problem that we have. So in this particular problem that we can apply a classification machine learning algorithms. Now main work that we have to predict if the particular users will click on an advertisement or not. Okay, the data consists of the 10 variables. So in our data set that we have the multiple variables called daily time spent on site, age, area income, daily internet usage, ad, topic line, city, mail, country, timestamp, and click and ads. Okay, so these are the some of the features that we have in our data set. Based upon these particular features that we want to predict, okay, so whatever the advertisement as a business or owner that we are going to run, our users they are going to click on those particular ads or not. Okay, because based upon those particular clickable ad, then we will get the benefit, right? Let's say if I am running any types of the business, let's say that I'm running some of the ads for my upcoming machine learning bootcamp course. Okay, now randomly that I'm going to select the users over the Facebook or over the Instagram or over the YouTube. Okay, and if I'm going to select the random users, then definitely let's say if I have selected above 60 plus or the 50 plus age group people, then definitely they did not require a machine learning project course, right? I want to target a 20 to 30 age group people, a male and female both, right? Then I will get some of the conversion, then I will get the good responses based upon my ad, right? So this is the main problem statement that we have. Okay, so whatever the advertisement that we are going to run over the different social media platform, our users they are going to click on those particular ads or not, based upon the certain features or the based upon the certain variables, whatever the features that we have in our data set. Okay, so this is the main problem statement that we have. The primary variable we are interested is in clickable on ads. So this is the main target column that we have. So based upon this particular target column that we are going to click, okay, so our users, they are going to click on the advertisement or not. Okay, now this variable can have two possible outcome, 0 and 1, where the 0 refers to the user who did not click the advertisement, while 1 refers to the scenario where the users click the ad. So we have two types of we can say the binary classification problem that we have, where we have only two features in our target column, 0 and 1. 0 refers to the, okay, so this particular users, they are not going to click over the ads. 1, it means yes, our users, they are going to click over the ads. Okay, now we will see if we can use other 9 features to check it out and to predict the correct accuracy. Okay, so these particular users, they are going to click over our ads or not. So this is the main problem statement that we have to check whether our users, they are going to click over our advertisement or not. Okay, now what I'm going to do, so these are the some of the features description that we have, whatever the features that we have in our data set, like a daily time spent on the site, so consumers time on the site in a minute, age, customer age in a years, area income, so average income of the geographical area of the consumer, daily internet usage, so average minute a time consumer is on the internet, ad topic line, so headline of the advertisement, city, so city of the consumers, mail, whether or not the consumers was male or not, because depends upon the our advertisement, based upon our product, we can target a male or the female. Let's say if I'm going to run an advertisement for the beauty product, in this case I want to target a female candidate, right? Let's say if I want to run any types of the course related, a data science course related advertisement, in this case I want to target a 20 to 30 or 35 in between the age group people, male as well as a female. So depends upon the advertisement. So that's why here we have a different types of the features. We can check it out the features. Okay, so which feature is more important that we have to get a clicked over our advertisement. Okay, now we have a country, so country of the consumer, time stamp, so time at which consumers click on the ad or close the window, clicked on ad, so 0 or 1 indicate click on our ad. Okay, so these are the some of the features introduction, or we can say the features description we have. Now let's try to import our all the important library, and based upon the library then we can load our data, and after that we can perform a complete operation. Okay, so here we are going to import our all the important library, so numpy, pandas, plotly to plot the complete graph, Shivon, okay, word cloud, so matplotlib. So these are the all our important library we are going to import here. Okay, after that we are going to load our data, so pd.readcsv, so whatever the data that I have, this is the advertisement.csv data that I have, and with the help of pd.read_csv function we are going to read our data. Okay, now if I show you our complete data, so here that I'm going to select top 10 data, so these are the complete feature that we have, the daily time spent on site, age, area income, daily internet usage, ad topic line, city, mail, country, timestamp, and click on the ad. So these are the some of the features that we have. Based upon these particular features, based upon this particular 9 features, then we are going to predict, okay, so whatever the users that we have and whatever the ads that we are going to run, yes, our users, they are going to click on those particular ads. Okay, after that here that I'm going to check the complete data type and the length of our complete variables. So for this one that I'm going to call the info function. In a pandas we have the inbuilt info function, so df.info, and with the help of this particular function that we are getting our complete description. So first that we are getting our column name, none, whatever the data that we have is the null value that we have in our data or not, a count of the data, and the data type. So we are getting the data type as well. Okay, so the ABC or the XYZ column that we have the integer data type or the string data type or the floating point data type. Okay, now after that here we are going to check the shape of our data. So this is the complete shape that we have, the 1000 rows that we have, and the total 10 features we have in our data set. Okay, now after that we are going to check, okay, so how many duplicate records we have in our original data set. So we have a total 0 duplicate results in our original data set. So this is the basics exploration that I have done, where we are going to check the our information of our data, shape of our data, columns of our data, of duplicate data. Okay, now what we are going to do, now we are going to check the missing data, a missing value in our all the features. So for this one, that we are going to write here a for loop. So for df dot columns, so from this particular df dot columns, that we are going to call one by one all the columns, because I want to check a missing value in my all the features. Okay, so we are going to iterate all the columns one by one, and after that here we are going to call a df is null function and dot sum. With the help of this one, that we will get, okay, so how many missing value we have in our particular column. So if I show you here, so as you can see, this is the complete output that we have, and based upon this particular output, in our every column that we have the 0 missing value. Even that I have mentioned here complete description. So observing the output of this code shown at there is 0% of the null value within the each column of the data. So we have a 0 null value in our all the data, in our all the features. Okay, now after that we are going to print our complete data. So for this one, that we are going to call a column, so df dot columns, and with the help of this one, that we will get our complete columns name, categoricals as well as a numerical columns name. So these are the complete columns name that we have for our data set. After that, what we are going to do, so we are going to select only the categorical data. So for this one, that we are going to call a df our data frame dot a select data type. So we are going to select a data type, and in a include function, that we are going to include a object. Object, it means the string data that we are going to include here. String, it means the categorical data that we are going to select. So in our data, that we have the categorical data like add, topic line, city, country, timestamp. So these are the complete categorical data that we have in our data set. Now here we are going to create one variable called numerical columns, and we are going to define all the numerical features or all the numerical columns, whatever the numerical column that we have in my original data set. Same way that we are going to create a categorical columns variable here, and we are going to define our all the categorical columns name. Okay, after that we are going to check our complete description, and df dot describe dot t, it means in a transpose mode. Okay, so we are going to check the complete description, a statistical description that we can say. So statistical description that we are going to check for our all the data. Okay, in this case, let's say if you want to check the for only categoricals or only numerical, then you can define the you can just include, you can define the parameter called include equal to string or a numerical data. Okay, here I already shown you. So describe the numerical data. So for a numerical data, that we are going to check the complete description. So in this way, it's totally up to us. We want to check a complete statistical distribution for categorical or a numerical data, so we can define those things. Okay, now after that, here as you can see, this is the complete description that we are getting for our complete features, whatever the features that we have in our data set. Now let's talk about one by one. So first, let's talk about the daily time spent time. So daily time spent time, here that I mentioned the complete description. So daily time spent on the site. So we see the users between the 32 minimum that we have. So if I show you the minimum value, so 32 that we have, and the maximum that we are getting a 91. So minimum 32 and the maximum 91. So we see users spend between 32 minute minimum to 91 minute. Okay, 91 minute maximum that we have, minimum 32 minute and the maximum 91 minute on the site, with the mean value of 65 minutes. So the mean value that we have, if I talk about the mean value for this one, so we have a 65 minute, which not a 65 I can say. So we can, yeah, 65 that we have, 65 mean value that we have, so which is quite large amount of the time. So this indicates that that is the popular site. Okay, because definitely, like if the people they are going to visit more than, let's say if the people they are visiting 30 minutes or the 40 minutes on one single website, in this case that we can say yes, it's a popular website that we have. So we would like to see if there is any correlation between the time spent on the site on the ad click. So later part that we can check the correlation as well in between our daily time spent on the site as well as our clicked ad features. Okay, next that we have the age. So if I talk about the age, so the minimum age that we have the 19, maximum age that we have the 61. So the users age range between 19 years to 61 years within the mean of the 36 years. So mean age that we have 36 years. So which tell us that the largest, the target users are adults. Okay, so most of the targets user that we have are adults user that we have. Okay, now if I talk about the area income, so the minimum area income that we have the 13,996 and the maximum that we have 79,484. And if I talk about the mean, so mean that we have the 55,000. Okay, so the minimum user income is around 13k and the maximum user income is 79k, which tell us that the users belong to a different social class. We would like to further investigate how the income is correlated with the our target column. Okay, so this is the some of the insights that we can find from our complete features with the help of statistical distribution. If I talk about the daily internet usage, so in a daily internet usage, as you can see, the minimum 104 and the maximum that we have 269. And if I talk about the mean, so mean that we have the 180. So here again that I mentioned, so daily internet usage ranges from 104 minutes to 269 minutes. Out of total daily internet users, so user spend quite large amount of the time over the website, which range from the 32 to 91 minutes. So if I show you here again, so 32 to 91 minutes, we will, like as you can see, the 32 to 91 minutes. Okay, so based upon this one that we are going to find out, okay, so how much MB, that how many minutes our users they are going to spend over the website. Okay, now if I talk about the male, so in a male, as you can see here that I mentioned, so 40% of the users are the male. So if I show you here, so as you can see, the mean that we have the 48%. So 40% of the users are the male. We will check if the genders affect the rate of the click on the ads or not. Okay, now next that we have here, if I talk about the ad clicks, so click on the ad. So yes, see that 50% of the ads were clicked on the 50% of the ad were not clicked by the users. So yes, 50% of the users, whatever the advertisement as agencies that we are going to run, our 50% of the users they are going to click over the our ads. Okay, so we can say yes, this is the like not good that we can say, because the 50% that we have, so we can say yes, average response that we are getting on our advertisement. Okay, so these types of the insights that we can find out from our data set based upon the statistical distribution, and based upon this one that we can proceed with the next steps where we can do the complete EDA, we can do the complete data analysis. Okay, now what I'm going to do here, that I'm going to do the complete summarizing numerical value. So again here that we will get the complete summarization about our numerical value. So here as you can see, as the mean and the median of the 50% of the very similar to our data. Okay, so this is the complete summary that we are getting for our numerical data. Okay, now after that we are going to summarize our complete categorical variable. So here as you can see, we are going to create a variable called object column. We are going to select our all the categorical data, whatever the categorical data that we have in our data set. After that we are going to iterate one by one our all the columns. So one by one all the columns that we are going to iterate, and then here we are going to find out the unique value from our data. So if I talk about the add topic line, so in our add topic line, total thousands unique data that we have. If I talk about the city, so in our city that we have total 969 unique city we have. If I talk about the country, so in our country data that we have a 237 unique country we have. Now timestamp, so yes, 1000. Okay, so these are the complete unique data information that we are getting for our all the categorical data. Now if I talk about the describe the, so here that we are going to check our all the categorical data. So describe the method is used to give the statistical information on our categorical column. So here we are getting our complete information about our complete categorical data. So add topic line, a city and the country. That I'm going to remove this particular timestamp. I'm not going to select this one because timestamp is not a categorical column, it's a date time column, right? Later part that we can handle this particular data as well, this particular features as well, but right now that we are going to select only add topic line, city and the country, because we all know like this particular all the features that we have a categorical data, but this particular timestamp is a date time feature we have. Okay, so later part that we can handle. Now as you can see, if I talk about the complete description, so if I talk about the count, so yes, this is the total count that we have, but the unique data that we have in a add topic line 1000, city 969 and the country 237. If I talk about the frequency, so the most frequency that we have France 9, Lismouth 3 and exclusive client 1. Okay, so this is the complete description that we are getting for our all the categorical data, even that I have mentioned here as well. So as we have many different cities and not many people belonging to the same cities, so frequency that we have here 3, so it probably means that this features has no or the very little predictive power. Now however, we have a less diversity with the country features, so we have to investigate further this particular country features as well. Okay, so these are the complete information that we are getting with the help of this particular code. Okay, after that what we are going to do, so now we are going to categorize our qualitative data as well as our quantitative data, or we can say the qualitative variables and quantitative variable. So here that I have mentioned, so we shall separate the quantitative as well as qualitative variables to summarize them, and this should give a bigger picture of what is going on in our data set. So that's why we are going to categorize our qualitative data as well as our quantitative data. Okay, so first of all that we are going to talk about the qualitative data. So here we have created a variable, and after that we are going to call here a df.select data type, where we are going to select our all the categorical data, so object.columns, and after that this is the complete qualitative data that we are going to select. Okay, now as you can see here we have our country, ad click, timestamp and the city. So as you can see here that I mentioned, what is interesting to note that pandas classify the timestamp variable as an object, but we all know this is the datetime feature that we have, so it appears in the section here. A timestamp is not a qualitative data that we have. Okay, later part that we can handle. Okay, now after that again that we are going to minus this one, so that I'm going to use a minus operator. Okay, subtractor operator. Okay, it's totally up to us, we can just select the 3 columns. So at the end that I want this particular 3 columns. Okay, now after that this is the same frequency that we are getting, so for the country, ad click and the city, so same types of the frequency that we have, so here the same types of the frequency that we are getting here as well. Okay, now after that we are going to check for the quantitative data. So again that I have created a variable, so quantitative column, a set.df.columns minus, we are going to minus or we are going to subtract our all the qualitative column. Okay, and then we are getting our complete quantitative variables, so timestamp, click on ad, daily timestamp, age, daily internet usage, area, income and the mail. So these are the complete quantitative variable that we have in our data sheet. Okay, again we have our complete summary, so here again that we are going to call the summary for our all the quantitative variable. Okay, same types of the variable that we have and the same types of the information here that we have. Okay, now after that we are going to work on our datetime column, so extracting the datetime variable. So now if I talk about here, so in this particular variable that we have our one of the column called timestamp, and if I show you the output in our timestamp data, so here as you can see this is the timestamp data that we have, and in this particular timestamp we have the year, month, date, hour, minute and second. So these are the complete information that we have. So what we are going to do from this particular timestamp, that we are going to extract the information. Okay, so that we will get, okay, so whatever the user that we have, how many minutes they are going to visit, how many minutes they are going to stay over the website, okay, how much internet based upon the timestamp they are using. So those types of the information that we will get. So that's why we are going to extract year, month, hour, minute, second, all the information that we are going to extract. So same thing that we are going to call here. So if I show you again here, so yes, here as you can see extracting the datetime variables using the timestamp column, so pd.datetime. So here we are going to extract the datetime. After that converting the timestamp column into the datetime object in order to extract the new features. So yes, month, here that we are going to call create a new column called month, day, hour, and after that we are going to call a day of the week, so weekdays. So df.timestamp we are going to call the df, so create a new column called weekdays with Sunday as a 6 and Monday as a 0. Okay, so we are going to start Monday 0 and then Tuesday 1, Wednesday 3 and so on. Okay, and after that we are going to drop the timestamp column to avoid the redundancy. So we are going to drop our timestamp column as well. So first we are going to extract a complete information, year, month, day, hour, weekdays, and after that we are going to drop our timestamp, because now we are getting our complete information, whatever the information that I want. Okay, so for this one that I'm going to create a separate features for month, separate features for day, separate features for hour, day of the week, and then we are going to drop our timestamp column. Okay, after that we are going to start a visualization, because now we have our complete data, now we have our complete day, now we have our complete month, hour, minute, second, so all the information that we have. Now we are going to start our complete visualization. So distribution of the daily timestamp with that. So this is the complete visualization that we are going to start. Okay, now first of all that we are going to plot a histogram. So ps dot histogram, so plotly library that I am going to use. So ps dot histogram, df a data frame, x column that we are going to call. Okay, so in which column that I want to plot a histogram. So daily time spent on site, so this is the column that I'm going to select. Color that I'm going to select as a click on add, so 0 or 1 that we are going to select. A template is a none, and this is the complete color that we are going to select. Okay, now if I show you the description here, so in a problem statement that I have mentioned the complete description. So if I show you here, so 0 or 1, so again here, so somewhere here that I mentioned 0 or 1 indicating that the clicking on ads or not. So yes, the variables can have the two possible outcomes, 0 and 1, where the 0 refers to the users who did not click on the advertisement. So what I'm going to do, let me copy this one and let me paste in our graph, so that a later part if required I will explain you in a detail. Okay, so here that I'm going to copy and paste. Okay, now as you can see in this particular graph, here we have two things, 0 and the 1, 0 and 1. So 0 refers to the users who did not click on the graph. So as you can see everywhere in if I talk about the daily time span, so if the peoples if they are spending more than, we can say a 60 minute, okay, so they are not going to click over the website, they are not going to click over the, not a website, over the advertisement. And if the people they are going to spend a less time over the website, they are going to click. So as you can see everywhere, so the count 8, here that we have the count 24, count 29, count 34, count 30, and so on the count that we have. Okay, so whenever the time it's get increased based upon this one, so whenever the users spend time, it will get increased over the website, the clickable chance it will get decreased. So whenever the user spend time, it will get increased, we can say the clickable ads it will get decreased, a chances of clickable ad it will get decreased. Okay, so yes, this is the complete graph that we have for this one. Now next that we are going to check the distribution of the daily internet with the ads. So daily internet with the ad, again that we are going to use the same code, whatever the code that I have here, I'm just going to change the variables name. Okay, so df our data, x, so this is the complete daily internet usage feature that we are going to select. A color, click on the ad, template none, and this is the complete distance that we have. Okay, now if I show you here, so again as you can see, so whenever I can say the internet usage, so daily internet usage it will get increased, the people's chances it will get decreased to click over the ads. Okay, so 0 it means not clicked, and 1 it means clicked over the ads. Now as you can see if I talk about the count, so yes, we have the good count, like in a initial, so 58, after that 82, 77, 71, 59, 45, and so on the, like we have the good information about. Okay, so the our users they are going to click over the our ads. Okay, now we have a top city with the daily time spent over the our website. So yes, we are going to create a variable called city daily time, pd.data frame. So we are going to create a data frame, we are going to apply a group by based upon the city, and then we are going to select our daily time spent. We are going to do the sorting first of all. So mean, we are going to calculate the mean, and then we are going to do the complete sorting in a ascending order. Okay, after that here we are going to plot our complete graph. So we are going to select our x, so px our complete plotly library dot bar plot city, this is the variable that we are going to call. Now x city variable, y a daily spend time, and the template, and then this is the color that we are going to define. So as you can see in our best city, so we have a daily time spent on the site is 91 minute. If I talk about the next, so yes, 91 minute, little bit changes that we have. So yes, everywhere as I can see the 91 minute, 95 second, 90.97 second, 90.7 second, 89.91 second, 89.8 seconds. So depends upon the city, the peoples they are spending like different little bit difference that we have in our all the city users. But yes, if I talk about the responses wise, so we have a response, good response, because 89 minute over the one website, it's a good like 1 hour approx, sometime 30 minutes or the 40 minutes or like 32 minutes, 35 minutes. So this is the good responses that we have over our website. Okay, now if I talk about here a top city with the area income, so yes, top city wise. So again we are going to use the same code, whatever the code that I have here. I'm just going to change our features only. So pd.data frame, so we are going to create a data frame, a group by operation that we are going to apply, a city, area income that we are going to call, and here we are going to apply a complete ascending order equal to false, it means in a descending order. Okay, now as you can see here that we have in a city and whatever the income that we are getting. So in this particular city that we are getting the income, a highest income called 79k, again a 79k, 78k, and the so on, like as I mentioned, ascending equal to false, it means the descending order that we are going to plot this particular graph. So here we are going to check a complete income based upon the city. Okay, so based upon the city that we are going to check our complete user income. Now top city with the average internet usage. So again that we are going to apply a group by operation, and based upon the group by operation that we are going to find out, okay, so based upon the city, how much internet our users they are using. Okay, so now as you can see based upon the city that we have here 269 MB daily internet usage, 267 UG, 261 MB, 261 MB, 259 MB, 258 MB, and the so on in a MB that we are getting a complete information. Okay, so in this ABC or the XY city, our users they are going to use a 200 MB or 250 MB or 270 MB a complete internet. Okay, so here we are getting our complete internet, a top city with the average internet users information. Okay, after that here as you can see investigating the country variable. So now we are going to investigate our complete country variable. So it seems that without feature engineering, the city and the country have a very little prediction power. So this is because they seems to be wide non-homogeneous. So let's confirm with the plotting and to do a complete operation, then we can confirm. Okay, so we can use a city or we can use our country column for a prediction purpose or not, or to build a complete model. Okay, so again that I'm going to use here a group by operation. So df.group by, here we are going to apply a country, and based upon the target column that we are going to apply a sorting. So sort values based upon the ascending order. Okay, so descending equal to false, it means in a ascending order. So in a country here that we have this particular country, so France, Liberia, Turkey, Australia. So these are the complete information that we are getting based upon our country. Okay, so in a France, how many people they are going to click over the ads? So 9 people. In a Turkey, 8 people. In Australia, 8 people, and the so on that we are getting for our other country as well. Okay, now a maximum number of the internet users belong to which city in the given data set. So here we are going to check. Okay, so in which country our maximum internet users that we have. Okay, based upon the data. So again that we are going to apply a cross tab, and here we are going to call our country column and then our target column clicked on add. Okay, now as you can see here, if I talk about the country column, so as you can see in Australia, 7 people out of 8 7 people they are going to click over the ads. If I talk about the Turkey, so yes, out of 8 people, 7 people they are going to click over the ads, 1 people they are not going to click over the ads. Okay, so again here we have the 90% of the accuracy that we have. 90% of the people they are going to click over the ads. Okay, now so on that we have for information for our other countries as well. So Hungary, South Africa, Libya. Okay, so these are the complete information that we are getting. 1, it means yes, our users they are going to click over the ads. 0, it means no, our users they are not going to click over the ads. Okay, now this output suggests that no one country has an overlap share in the data. Okay, now the maximum number of the internet users belong to which country in a given data set. Here that we are going to check. So maximum number of the internet users belong to which country, and here we are going to, okay, so again we are going to check with the country wise. So here we are going to check a country wise with the total count. We are going to check a total count. Here we are going to check, okay, so out of internet user, out of 10 internet user or out of 9 internet user, how many people they are going to click over the ads or not. Okay, so based upon this one that we are getting here, because that's why we are going to pass our target column. So yes, in Australia country, out of 8 people, 7 people they are going to click over the ads, and 1 people they are not going to click over the ads. Okay, now below that we are going to find out all the internet users belong to a country. So in a France that we have a total 9 internet user. Now right now based upon the data that we have the 9 only. Afghanistan 8, Australia 8, Turkey 8, South Africa 8, and the so on other information that we have based upon our country. Okay, so this is the total internet users information that we have. Okay, after that a top city with the average internet. So here if I talk about the top city, so top city that we have, so these are the top city that we have. So yes, Malaysia, in a Malaysia like the daily internet usage that we have a 242 MB, look like it's people by one people they are using a 242 MB. So on for the other city that we have. So yes, so on for the other city. If I talk about the India, so in India 235 MB per people they are using a internet. So this is the complete information that we have. Again that we are going to apply a group by operation, and with the help of group by operation that we are going to find out. Okay, so in our ABC or the XYZ city like the Australia or the India, like how much MB per people they are using. Okay, a complete internet. Now after that a top country with the daily time spent. So daily time, now same group by operation that we are going to perform here. So now here let me check it out. So yes, now daily time spent on the side that we have the 89 minutes, 88 minutes, and so on. So highest that we have our 89. If I talk about some other cities, so here's Sri Lanka 82 minutes, Nepal 82 minutes, Germany 82 minutes few seconds. Okay, and so on. Let me check it out for the India as well, because in our data set that we have the India information. Okay, so as I have selected, look like how many data that I have selected. So 20 country that I have selected. So based upon the 20 country that we are not getting the India information here. So look like the daily spent by our India country is out of 20. So that's why here we are not getting the information. Okay, now after that, next that we have the top city with the area income. So now we are going to find out the area income with the city. Okay, so again we are going to use a complete group by operation again. So country and the area income. So country wise, so top city, so this is city or Jordan, Benin, Pakistan. No, so this is the country, not for the city. As you can see here that I'm calling a country, right? So let me change this particular comment as well. So this is the country. So yes, so country wise that we are going to check the complete income. So yes, in this particular country that we are in a Jordan that we have the 74k, again 71, Finland 70, now 69, 69, 69, South Georgia 69, 68, now 68, 66, 66, 66, 65, Pakistan 64, and so on a country wise that we are getting our complete income, area income information. Okay, now next that we are going to extract the features for the visualization purpose. So here that I'm going to check the same thing. Okay, so in Australia, how many people out of 8, how many people they are going to click over the ads, or how many people they are not going to click on the ads. Okay, for our all the countries. So here that I'm going that I have selected only 10 countries. So based upon the 10 country that we are getting here a complete information. Next we are going to check the complete country wise count. So okay, so in which country how many users that we have, like how many users they are going to visit over our website. So if I talk about the total count, so in a France 9, Afghanistan 8, Australia 8, and so on for our other country. Again that I have selected only 10 features here. Okay, so here that we are getting a complete information regarding our users. Okay, so these are the complete like 9 users that we have in our France, in Afghanistan that we have the 8 users, in Australia that we have the 8 users, and so on based upon the country that we are getting our complete user information. Okay, so how many total users that we have based upon the country data. Okay, now after that, as you can see here that I have mentioned our complete comment. So we have already seen that there are 237 unique countries that we have in our data set, and no single country is too dominant. A large number of the unique elements will not allow a machine learning model to establish easy value relationship for the region. This variable will be excluded too. So that's why we are going to check it out a complete information. Okay, so how many users that we have a total users, and out of total users how many users they are going to click over the ads, and how many people they are not going to click over the ads. Okay, now after that here we are going to do the complete distribution. So distribution of top 12 country ads click based upon the gender. So based upon the gender that we are going to check here. So here again that we are going to plot a count plot. So SNS dot count plot, we are going to define X as a country. Here that we are going to define our target column. So equal to 1. It means yes, the people they are going to click over the ads. Okay, now order. So df a click equal to 1, and here that we are going to call a country value counts, and we are going to select a top 12 country that we are going to select, and hue that we are going to select a male. So here in a hue 1 it means the male that we have, a 0 it means the female that we have, other gender that we have. Okay, now after that here we are going to define a title, and then we are going to do the complete plotting. So based upon the plotting, as you can see in this particular, if I talk about the Australia, so in Australia that we have the less male member that we have, but if I talk about same time, if I talk about the Turkey, so in a Turkey that we have the more male member that we have, and the more male members they are going to click over the ads. Okay, same if I talk about for some other countries. So again, but like in a Turkey as well as Ethiopia that we have the more male members, and they are going to click over the ads. Okay, apart from this one, these are the female that we have. So the 0 it means the female that we have, or the other gender. Okay, so most are the developing countries, and the females are the active contributors. So as you can see, these are the active female contributors that we have in other countries apart from the Turkey and Ethiopia. Okay, next, hourly distribution of the ad clicks. So here we are going to check the hourly distribution of our ad clicks. So for this one that we are going to create a complete pivot table. So this is the variable that we have created. We are going to create a pivot table, variable df our data frame, index our that we are going to pass, a column male our gender column, value clicked over the ad or not, and then we are going to plot our complete data. So now as you can see, this is the information that we have regarding our gender, and this is the hour spent. So if I talk about the here, if I talk about the first data, so our in the first data that we have the more female active member that we have as compared to a male. So in a male that we have the only 10, but in a female that we have the 16. Again if I talk about the 1 hour, so again a 9 more member, 7 a less member, 9 female member and 7 less male member. Again if I talk about the 2 hours, so again male that we have the less here because 7 that we have, but if I talk about the 3 hour or 4 hour, so in a 3 and the 4 hour that we have the more a male member that we have. Okay, so based upon this one that we are getting, okay, so like male and the female, how many hours they are going to spend over the our complete ads as well as over our website. Okay, now next that we have the distribution by each hour and by gender. So here we are going to plot a distribution by our complete gender. Okay, so here look like I need to run the complete graph. Okay, so you can run it out, okay, from your end, but the overall, as you can see here that I mentioned, so as we can see the uneven daytime frequency, females are the main contributor exceeding the male several hours. Okay, so again that we will get a complete females they are using they are expending more times over the website. Okay, so the frequency of the female is more as compared to male. Okay, male gender. Again a daily distribution of the ad clicks. So again that we are going to do the complete plotting, and based upon this one, again as you can see the female a more contributor that we have a female. So in a 6 that we have the more contributor in a big days 6. Again in a 4th day again that we have the female. Again if I talk about the first day, so female 0 it means Monday, 1 it means Tuesday, and the so on 6 it means a Sunday, right? So Sunday that we have the more female contributor, Monday we have a more female contributor, Tuesday that we have the more female contributor. Again if I talk about the Wednesday we have a male contributor, more male contributor. Again if I talk about the next day, so again we have the more male contributor, and the so on that we are getting our complete information. Now after that we are going to plot a factorial plot, and with the help of factorial plot that we are getting our complete outliers. Okay, so in which day that we have some of the outliers. So in a day 3 that we have the outliers, day 4 that we have, and the day 6 that we have, as well as a day 1 that we have some of the outliers. Day 1 it means the Tuesday. Okay, so we have some of the outliers in our sum of the day. So later part that we can check it out. So comparison of users who have clicked on ad or not in the terms of age and the big days. People of the higher age tend to the clicked on our ads. So as you can see, if I talk about the based upon the age, so here that we have the hour, and here that we have our complete age. So if I show you here, so as you can see, this is the value that we are getting and the weekdays data that we are getting. So based upon the weekdays data, so 0 it means not clicked over the ad, 1 it means yes clicked over the ad. Okay, so yes, if the peoples they are going to spend a more time over the website, in this case they are going to spend, or they are going to click over the ads. Okay, so the line chart here indicates that the user tend to the click on the ad later in the day, or the probably early in the morning. So as you can see, yes, it expected based upon the age features that most people are working, so it seems appropriate as they either find time early or the late in the day. Also, Sunday seems to be effective for clicking on the ad from a bar chart. So again, this is the complete information, and this is the complete insights we are getting from our data. Okay, next that we have the most of the days ladies clicked ad more than the male expect weekdays, a Wednesday and a Thursday. Okay, so the female, most of the time the ladies the female members, they are going to click over the ads expect Wednesday and the Thursday. Again, based upon this particular graph, again that we can check it out. Yes, so the male member that we have the more as compared to a female Wednesday and a Thursday. Okay, now after that, here that we have the complete monthly distribution of our ad clicks. So monthly distribution of our ad clicks. So here, as you can see here, if I talk about the first month, so yes, again that we have the female, second month female, third month that we have the male, fourth month we have a female, and so on. Only the 1 month that we have the third month that we have the male only, more male people. Okay, throughout the year, ladies click on the ad is the most expected of the month is a March. So if I talk about here, so as you can see, a most expected of the month that we have a March, a third month. Okay, now after that, here that we are going to do a complete factorial plot. So yes, this is a complete factorial plot that we have. After that, again that we are going to plot a complete graph for our line chart as well as a bar plot that we are going to plot. So as you can see here, we are going to select a month as well as a clicked on the ad equal to 1. It means yes, our users, they are going to click over the ad. Okay, so same types of the information that we are getting. So as you can see, the line chart showing the count of the click for each month. Group var chart show the distribution of the target variable across the 7 month, and second month seems to be the best of the clicking of the ad. So as you can see, the second that we have the best results on the clicking on our ads, male as well as a female members. Okay, now here that we have our complete. So now we shall group by the date and the time and the see. Okay, so how much people in which time that we are going to, like the people they are going to click over the ad. Okay, so here as you can see, we are plotting the complete graph. So based upon this particular graph, so this is the complete date wise distribution that we have to click over the ads or not. Okay, now that we are going to select the top ad click on the specific date. So yes, on this particular specific date that we have the 8 users, they are going to click over the ad. After that 7, and so on based upon the date that we are getting a complete information. Okay, so in which date how many users they are going to click over the ads. Okay, now as you can see, on the 14th February 2016, we saw most 8 click on the ads. So the Valentine Day is the best selling day for the company ad. So based upon the product, like the people they are going to purchase and they are going to click over the ads. Okay, now let's see the daily internet usage and the daily time spent on the site based upon the age. So here that we have our complete based upon the age as well as based upon the age group that we are going to check. Okay, so the people they are going to spend over our website based upon the age. So yes, as we can see, the people around 30 years. So people around 30 years, the population devote a lot of their time on the internet and the site, but they don't click on ads that frequent. Okay, now compared to them around 40 years, population spend on the bit less time but clicks on the ad more. So if the people their age is above 40 or around 40, then they are going to click over the ads. So based upon this particular graph that we are getting our complete information. Okay, so this is the complete time spent that we have, and this is the complete internet usage that we have based upon the age group. Okay, After that, here that we are going to check the unique data. So yes, 1000 unique data that we have. Now we are going to check the all ad topics are the different, which makes it really difficult to fit to our model. So here what we are going to do, so here based upon the our ad topic line, we are going to check, okay, so which topic is more important, or the which advertisement tag, or we can say the headline that we have the importance. So based upon the word cloud, so yes, word cloud, we are going to use a word cloud function, and with the help of word cloud library that we are going to use, and based upon this one that we are going to use, okay, so which word is a more important or the most frequent usage word that we have in a advertisement. So as you can see, yes, configurable or solution, front, line, so these are the more, we can say, the more usable word that we have, or more used word that we have in our data. Next graph that we are going to plot a pair plot. So distribution and relationship between the variables. So creating a pair plot with hue defined by the clicked on add column. So target column that we are going to call here. So SNS dot pair plot, where we are going to define our data frame. In a hue that we are going to call a clicked on add column, our target column, and here we are going to define our all the variables like daily time spent on site, age, area, income, daily internet usage, and so on, about all the parameters that we are going to call. So this is the complete pair plot that we are going to plot here. Here a target column that we are going to define as a hue. Okay, now here that I mentioned our complete information, our complete understanding. So the most exciting part of this graph is to pronounce a difference between the people that click on the ads and people that did not click over the ads. Okay, furthermore, all the variables bear no correlation to each other, so we did not have any other correlation in this particular pair plot. Okay, so you can just read it out, this particular complete information from here. Next that we have the let's plot a two-dimensional density plot to determine the interdependence of two variables. Okay, so let's see how the user age and the time span on the sites are linked with each other. Okay, so for this one that we are going to plot a join plot. So SNS dot join plot, we are going to call area, income columns, df dot age, so age column that we are going to call, and this is the complete color that we have. Okay, so this is the complete graph that we are getting. Now next that we are going to plot with respect to daily time spent on the site. So for this one, this is the graph that we have, and here that I mentioned the complete description. So from the picture we can conclude the younger users spend more times over the website, so more time on the website. This implies that the user between the 20 and 40 years can be the leading a target group for the marketing campaign. Hypothetically, if we have a product intended for a middle-aged people, this is the right side for advertising. Okay, now if we have a product designed for a people over the 60 year, in this case it would be the mistake to advertise on this particular site. Okay, and so on that I have mentioned our complete information. So this is the main information that we have. So let's say if we have a product for a 20 to 40 years age group people, in this case this is the website that we have to advertise our product. Else if we have a product designed for the above 60 year age group people, in this case that we need to find some other website for the advertisement purpose. Okay, now next that we are going to plot a complete graph. So again a KD plot that we are going to plot. So CMap SNS dot Kubelik plat, so this is the color that we are going to define, and after that we are going to call our daily time spent site as well as our internet users. So how much time our users they are going to spend over a time, and how much internet they are using on the daily basis. Okay, so this is the complete graph that we have. So as you can see the daily time spent on the site, and this is that we have a daily internet usage. Okay, now for the further figure, it's clear that the user who spend more time on the internet also spend more times on a website. Okay, so it means like if people they are going to spend more times over the site, in this case it might be possible they can click over the advertisement. Okay, now after that we are going to do the plotting for our all the columns for our daily time spent on the site, age, area, income, a daily internet usage. So for this particular all the features that I have selected, and after that I'm going to plot a box plot as well as a disk plot. Box plot, and along with the box plot that we are going to plot a disk plot as well. So this is the complete box plot and the disk plot graph that we have. So daily time spent on the site, age group, area, income, and the daily internet usage. Now here that I mentioned the complete description, so we can see that the daily internet usage and the daily time spent on the site has the two peak. So if I show you here, so as you can see this is the peak that we have. So the first peak that we have the 80, and if I talk about the daily internet users. So here that we have the two peaks, the first one is this one and the second one is this one. Okay, now it indicates that there are two different group present in our data. So we have two different group peoples in our data set. We don't expect the users to be generally distributed, as the people spend more times on the internet or the website, and the people who spend less time over our website. Some regularly use the website and some less often, so they are perfect, all right. Okay, so as per the data that we are getting the understanding. Okay, so some people they are using the less internet, but whenever they are using the internet, they check our complete website. So again, this is the best website that we have, whatever the website data that we have. So it's a website data that we have where we can do the complete advertisement. Okay, now let's see the age distribution. So here that we are going to check the complete age distribution. So again, this plot that we are going to plot, so it can be concluded that the variable age has a normal distribution. Even that we can check it out here, the age this particular this plot graph is a normal distribution graph that we have. Okay, now after that we are going to check the max, mean and the mean value. So oldest person was 61 years, youngest person was 19 years, and the average age was 36.0. okay, we can say the 36. Okay, so this is the complete age years that we are getting. So 16, 19 and the 36. Now what we are going to do, so we are going to check the clicked versus not clicked. Okay, so here we are going to apply a group by operation. So df dot group by, we are going to select our target column, and apart from this one that we are going to select a daily time spent on the site, age, area, income, as well as a daily internet usage. Based upon this one that we are going to calculate a complete mean. So now here that we have the data, so clicked on the ad. Okay, so 0 and 1. So 1 it means clicked, 0 it means no. Okay, now daily time spent on the site. So 76 we can say the minute, or yeah, 76 minute. In a minute that we have our complete data, and for yes we have a 53 minute. Now if I talk about the age group, so for no that we have the 31, and for yes that we have a 40. Area income 61,385 for no, and for yes that we have the 48,000. Now daily internet usage 214 for 0 it means no, and 145 for 1 it means yes. The people they are going to click over the ads. Okay, now average profile of the user who will click on the ad or not. So here as you can see that we are getting the complete data. So here we have a male 0 and 1, so we have a female or male, and here that we have the clicked on the male. So 0 it means the female that we have, and if I talk about in this base, so here that we have the 0 it means no, not clicked. Okay, so 250 people they are not going to click over the ads, and those people are the female that we have. Now if I talk about the female peoples, they are going to click over the ads. So yes, 269 female people that we have, and they are going to click over the ads. Now if I talk about the male, so in a male again that we have the 200 peoples, and those 200 peoples they are not going to click over the ads. Now if I talk about the click over the ads in a male, so we have a 231 male people, and they are going to click over the ads. Okay, so this complete data is look like a confusion matrix. Okay, but you can compare with this one, a male that we have the 0 and 1 this one, and the click ad data that we have a 0 and 1 this one. Okay, based upon this one that we can do the complete analysis. Okay, now after that here that we are going to plot a complete graph. So male we have selected the 6, and we have selected the complete count for this one. So count x as a 6, y as a count, and the color that I am going to select as a 6. Okay, now here as you can see this is the complete graph that we are getting. So 0 it means female, and 1 it means a male. Okay, now after that distribution of the click by the gender, it seems that more number of the females have the click. So if I show you here, so as you can see how many female member that we have, 519. Same thing that I have mentioned here. So it seems that more number of females have clicked on the ad. Now if I talk about the male, so male that we have the 481. Okay, now next that we are going to visualize our complete data. So visualizing a target variable clicked on the ad. Okay, so again that we are going to plot a complete this plot and the count plot that we are going to plot. So here as you can see this is the complete graph that we have. So here 0 it means the female, 1 it means a male. Okay, so the graph above demonstrates that the data is roughly 50-50 if the users click on the ad. Okay, so from the plot we can see that the number of the users who click on the ad and who do not click are equal in the number. So that is 500 which make it easy and very interesting, because the 50-50 data that we have, the 50% people they are not going to click over the ad, and the 50% of the people they are going to click over the ad. Okay, so the 50-50 we can say the balanced data that we have here. Okay, now after that let's see a click on the ad feature based upon the sex. So based upon the gender that we are going to check male and female. Okay, so again that we are going to plot a count plot here. So yes, this is the complete graph that we have, and if I show you, so here that we have, this is the zero data that we have. Okay, and this is for the one data that we have, where the people they are going to click over the ads. So as you can see, the female tends to click more on the ads. So based upon the above insights, again we all know like the female people that we have the more people, and they are like more female people they are going to click over the ads. Okay, now after that here that we are going to plot a box plot. So again in this way that we will get the some of the outliers as well. So if we have any types of the outliers, so with the help of box plot, apart from this one that we have some other method as well, like the scatter plot, and with the help of scatter plot again that we can check it out. Okay, so in our data that we have the outliers or not. Okay, so here we are going to plot a box plot. So as you can see, if I show you here, so yes, this is the outlier that we have in this particular daily time spent on site data. Okay, now here that we are going to check the age over the color that I'm going to select the click on the ads again. So again here that we have the 3 outliers data. If I talk about the area income, so again in a area income that we have some of the outliers, 4 to 5 outliers that we have. Now if I talk about the daily internet usage, so in a daily internet usage, one people that we have, they are using 146 MB on daily basis. Okay, now here that we are going to plot a complete disk plot graph on our all the numerical columns. So we are going to iterate one by one all the columns, and this is the graph that we are going to plot. So yes, this is the graph that we have, a daily spend time based upon the target column. So yes, we all know in our daily spend time features we have some of the outliers. Again in our age column we have some of the outliers, in our area income we have some of the outliers, in our daily internet usage we have some of the outliers. Okay, so with the help of this one that we are getting, okay, so we have some of the outliers. Apart from this one that we are getting, okay, so like our data is tend to the right skew side or the left skew side. Okay, so as you can see here, this particular data that we have in a left skew side, that we can say this particular data that we have a little bit a right skew side. Okay, so on for this one, so this one that we can say yes, little bit fine data that we have. So this one is fine, again this one is fine that we have. Okay, now next what we are going to do, so again next that we are going to do the plotting for our like violent plot that we are going to plot male age, gender and age versus clicked ad or not, weekdays, again a male and the daily spend on the site. Okay, so here that we are going to plot a complete violent plot. So this is the complete violent plot graph that we have. Okay, now let's see the distribution of who clicked on the ad based upon the area income of the sex, because in every area we have a different types of the people, a male as well as a female, different gender people that we have. So what we are going to do now based upon the area income that we are going to check. Okay, so we have the more male member or the female members they are going to click over the ads. Okay, so again that we are going to plot a violent plot, and based upon the violent plot this is the complete graph that we have. And now as you can see, both male and the females with the area income less than 50k are the main customer of the ad. Okay, now like almost all whose income more than 60k are not interested in clicking on the ads. Okay, now so this is the complete conclusion that we have. So in conclusion, mostly around 40 years female within the income group less than 50k in developing countries are the primary consumers of our ads. Okay, and they are interested in our ads, and after that they are going to click over the ad. Okay, so based upon this particular graph that we are able to understand, okay, so in which income group peoples they are interested in our ads, so that we can target a same people. Okay, now after that we are going to plot a distribution plot again. So here this is the complete distribution plot graph that we have, and I just clear above around 40 year population are the most contributor to the ad clicking, and not approximately 30 years. Okay, so based upon this one that we are getting, okay, so the most of the like 14 years population peoples they are going to click over the ads. After that we are going to plot a scatter plot over the our daily time spent on site as well as x column age column. So this is the complete data that we have. So if I talk about this one, so here as you can see, so this is the age data that we have, and the 40 age and the peoples daily they are going to spend 89 MB 89 MB, and if I talk about, okay, so they are going to click over the ad or not, so 0, it means no, they are not going to click over the ad. So this is the yellow one people, they are going to click over the ad. Okay, all the yellow one people, they are going to click over the ad. So based upon the age, as you can see, the people's, whenever the people's age, it will get increased, the people's, yes, they are clicking over the ads. Okay, now next, based upon the area income, so again the based upon the area income, the people, they are going to click over the ad. So again the yellow one is a yes, the people, they are going to click over the ad. Now if I talk about the daily internet users, so yes, if the people are using more internet, in this case, no, we can't say directly the more internet, because as you can see, this is the graph that we have. Okay, so based upon this particular graph, so if the people are using the less internet, we can't say, because this is the less internet, daily internet data that we have, and this is the age that we have. So yes, the people, they are using a more internet, but based upon the gender and based upon the age group, our complete customers, they are divided. So first, based upon the age, as you can see, the if the people's age is greater than, we can say, till 60 and 60 years, till the 60, 55, 60 age group people, they are going to click over the ad. Okay, now with respect to our daily time spent on the site, so yes, if I talk about this one, so as you can see, the peoples, they are using a more internet, okay, but if I talk about the spending, so yes, as you can see here, the people's daily time spent on the site is 79, daily internet usage is 217 MB, but if I talk about the click on the ad, 0, it means no, they are not going to click on the ad. Now let me check it out for other data. So yes, here that we have a daily spend time on the site is 78, a daily internet usage is 131, but yes, they are going to click over the ad. Okay, so based upon this particular graph, as you can see, that we are getting information. Okay, so people are like spending more times over the site, but they are using a less internet, and in a less internet timing, they are going to click over the ad. Okay, now after that, here that we have with respect to the income, so again with respect to the income, that we are going to check it out. Okay, so the peoples are going to click over the ad or not. Area income, mainly for the area income. Okay, after that, we are going to plot a complete correlation plot between the variables. So again, heat map that we are going to call a df.cord, and here that we are going to plot a complete graph. So degree of the relationship between the correlation using the heat map. So this is the complete correlation that we are going to plot here. Okay, here that I have mentioned the complete description. So heat map give us the better understanding of the relationship between the each other. Correlation is measured between the -1 and 1. The higher the absolute value, the higher is the degree of correlation between the two variables. It means if the value is higher, we can say that we have a correlation between the two variables or the two features. Okay, we can accept a daily internet usage and the daily time spent on the site to correlate more with our target column. So let me check it out. A daily internet usage. So this is the daily internet usage that we have, and the daily time spent. So if I talk about the daily time spent, so yes, daily internet usage and the daily time spent. So here that we have the 0.52, and this is the higher data that we have. So we can say we have a correlation between this particular data. None of our explanatory variables seems to be correlated with each other, indicating no correlation between our others data. Okay, so as you can see, this is the main graph that we have for our correlation plot, and with the help of this particular correlation plot, that we are able to understand. Okay, so we have some of the correlation between our daily internet usage and the daily time spent over the site features. Okay, now that we are going to check the outliers. So outliers, identify the potential outliers using the IQR. So here that we are going to apply a IQR method, and based upon the IQR method, that we are going to find out. Okay, so in our data that we have the outliers or not. Okay, so here we can use IQR method. So for any quantitative variables points greater than 1.5 into IQR, so 1.5 into IQR above or the below, the upper and the lower quantiles are assumed as a outlier. So based upon this particular formula, that we are going to find out. Okay, so we have the outliers in our variables or in our features or not. Okay, so for this one, first of all, that we are going to define our complete variables, our complete features. We are going to create a data frame, and after that we are going to write a complete conditions. So IQR, upper limit and the lower limit, and based upon this particular upper limit, lower limit and the IQR, that we are going to calculate our complete outlier. So yes, this is the complete data that we have. So first that we have a count, mean, standard deviation, minimum 25, 50, 75, maximum data, So now daily spend time on the site. Okay, now no outlier found in a daily spend site. Now if I talk about the suspected outliers lower bound, so this is the lower bound data that we have, and this is the upper bound data that we have. So in our daily time spent on the site data, we did not have the any types of the outliers. Now let's talk about the age column. So again, no outliers found in the age data. Next that we have the area income. So yes, we have some of the outliers in our area income. Okay, so we need to handle it. Now next, daily internet usage. So we did not have the outliers. So in our only one data, number of the outliers rows are 9. Okay, so in our 9 rows we have the outliers in our area income column. In our 9 rows we have some of the outliers. Okay, so if I show you here, so again, number of the outliers in our outlier data frame. So in our number of the area income, we have some of the outliers, only one features. Okay, now this is the complete data frame that we have. So from this particular data frame that we are going to check it out. So in this particular data that we have some of the outliers in this particular rows. Okay, so this show that the 9 people could be classed as a outliers. These all belong to the area income variable. So as I mentioned here, so yes, in our area income column we have some of the outliers. Okay, now after that, area income variable, because of this we would not order this outliers as they could come from the low income areas. Okay, so unless furthermore, unless the data shows the area income is incorrectly, or there is misunderstanding in how that variables was created, so there is no need to remove this particular outliers, because at the end here that we have the only 9 outliers in our area income column. Okay, so that's why we are going to keep this particular outliers right now. Later part, if it's affect over our model, in this case that we can remove or we can handle it. Okay, now after that we are going to do some of the statistics implementation. So t-test and the f-test between the groups of the people that clicked on our ads. Okay, so before applying the t-test, it is a good idea to check if our data is usually distributed or not. Okay, so we also need to figure out if there are a difference in variance. Then we need to think carefully about whether the testing for a difference in the mean value is helpful or not. Okay, so before applying this particular t-test and the f-test, that we are going to check, okay, so our data, whatever the data that we have, those are the distributed data that we have or not. Okay, so here we are going to calculate the variance. So again, that we are going to call our all the data, all the features. We are going to write a for loop, and based upon the for loop that we are going to check the complete variance. So simple variance for daily time spent on the site of non-clicked is 57 and clicked for 164, and the difference variance that we have the 107. Okay, now if I talk about the age, so variance that we have 39, and if I talk about the for our next column called area income, so for the area income that we have the this one, so approx is a huge value that we have for the area income. Okay, now if I talk about the daily internet usage of the non-clicked or the clicked, so here that we have the variance is 331. Okay, so this difference in the variance are hugely different, so there is really no need for f-test here. So there is really no need for f-test. We can quite confidently say that the variance between the two groups of the peoples are different. So this could explain the scale difference between the two distribution. Okay, so that's why here we are not going to perform a f-test. Okay, so now let's jump into our t-test. So now let's test if the means are different. So that's why we are going to check the mean here. So here this is the complete mean that we have. So here we have checked the variance. Now we are going to check the mean. So for the time spent on the site, we have the mean is 23. For age we have 8. For income we have approx 12,771, and internet usage for this one that we have the 69. Okay, so this is the complete mean that we are going to calculate. Now we can see that the daily time spent on the site and every internet usage have the apparent difference in the mean. So if I check again, so here we have the daily internet usage, and here that we have the daily time spent. So we have some of the difference in the mean. Now age and area income is not as clear. However, the t-tests are needed to determine if these groups are different or not. Okay, first we need to do a test if these variables are normally distributed. Before applying a t-test, it is a good idea to check if our data is separated or not. Okay, our data is spread or not. Okay, after that we also need to figure out if there is a difference in variance. Then we need to think carefully about whether a testing for a difference in the mean values is a helpful or not. So here that I have mentioned again a complete description. So based upon this particular description that we can understand. So this is the complete mean that we are going, difference is a mean, and here that we are going to check a difference in a variance. Okay, now after that a testing for normality. So again the null hypothesis H0, the data is normally distributed. Alternate hypothesis H1, a data is not normally distributed. So here that I mentioned the complete, and the significance level alpha that I am going to select 0.05. Okay, so this is the alpha that we have, alpha value that we have. Now here we are going to define our alpha value, and after that we are going to check our complete null hypothesis and alternate hypothesis. Okay, so now let me check it out here. So here that we have our complete result. So result for non-click daily spend time on the site, statistics is this one, and p value is this one. The null hypothesis can be rejected first. Now if I talk about the second column, so second feature, click daily time spent on the site, so the null hypothesis can be rejected. So 2 column is null hypothesis is rejected. Now if I talk about the result for the age, so again the null hypothesis can be rejected over our age column. Okay, for non-clicked, again if I talk about the clicked, so again rejected. Again if I talk about the area income, so null hypothesis can be rejected. For clicked, again are rejected. Okay, now daily internet usage rejected, and for clicked again null hypothesis can be rejected. So strongly none of the distribution is normal. So the distribution of daily internet usage of the people who clicked on the ad is far from being a normal distribution. So yes, we did not, like in our data we did not have a normal distribution data. Okay, so because of none of the distribution can be assumed to be expected, a non-parametric test would be more robust here. A both sample can be taken not via normally distributed, and both can be considered independently. Okay, so now what we are going to do, so now we are going to apply here U test, so man U test. Okay, again that we are going to define a null hypothesis. A data of the people clicking on the ads is distributed the same people not clicking on the ads. After that alternate hypothesis, so data of the people's clicking on the ad is distributed the not the same as the people's not clicking on the ads. Okay, again that we are going to select the significant level alpha equal to 0.5, and after that this is the complete output that we are getting. So result of the daily spend time on the site, so the null hypothesis can be rejected. Again for the age, null hypothesis can be rejected. For the area income, null hypothesis can be rejected, and for the daily internet, null hypothesis can be rejected. Okay, so this is the complete analysis that we have done till now. We have performed a complete ADA, we have performed a complete visualization, that we have checked the outliers, we have checked the missing value, we have checked the imbalance data, we have performed the complete statistics. Okay, so till now whatever the thing that we have, so this is all about a data analysis part. Now what we can do, now we can start with the model building. First of all that we can perform a feature engineering steps, and then we can start building a model. Okay, now let's try to build a complete model. So here we are going to use a multiple machine learning algorithms, and based upon the multiple machine learning algorithms, then we can select our final model. So what we are going to do, first of all we are going to load our all the important library again. After that we are going to load our data. So whatever the advertising.csv data that we have, so we are going to load here our complete advertising data. After that we are going to check here top 10 rows from our data set. Okay, now again we are going to extract some of the important information from our timestamp column. So we have one of the timestamp column. So if I show you here, so yes, and in this particular timestamp column we have our year, month, date, hour, minute, second, so lots of things that we have. So what we are going to do, so from this particular timestamp features we are going to extract year, month, day, hour, week. So these are the information that we are going to extract from our timestamp features. Now after extracting all the features, these are the complete value that we are getting. So month, day, hour, week. So these are the information that we are going to extract from our existing column called timestamp. Okay, after that we are going to build our basics model here. So basics model building based upon our actual data without applying a feature engineering step. Later part that we can apply, but here let's try to build first of all the basics model. So what we are going to do, first of all we are going to split our data. So for this one that we are going to import a train test split from a sklearn.model selection. After that, we are going to divide our complete dependent and independent features. So X, here we are going to define our complete data, and in a Y that we are going to define our target column. Okay, after that we are going to split our complete X and Y. So train test is split, X train, X test, Y train, Y test, that we are going to define, and X and Y dependent and independent data that we are going to call here, and 70% of the data we are going to use for a training purpose, 30% of the data we are going to use for the testing purpose, and after that random state equal to 42. So this is the complete data that we are getting. So X train 700 rows and 5 columns. If I talk about the Y train, so 700 rows we have. If I talk about the X test, so yes, 30% that we have 300, and for Y test 300 data that we have. Okay, so these are the complete X train, X test, Y train, Y test data that we have. Now let's try to build our first a basics model called a logistic regression. So from sklearn dot linear model import, that we are going to import a logistic regression here. After that we are going to create an object here, and then we are going to fit our complete data X train and Y train in our logistic regression model. After that we are going to do the complete prediction here. So yes, this is the complete prediction that we are getting based upon our model, whatever the logistic regression model that we have used. Okay, so this is the complete top 20 prediction that we have. Now we are going to check a complete matrix. We are going to check our complete performance of our model. So we have our performance matrix in a classification problem like confusion matrix, accuracy, precision, recall, F1 score. So those are the complete matrix that we have, and based upon those particular matrix we can evaluate our classification machine learning model. Okay, now what we are going to do, so here we are going to check our complete classification report. So first of all we are going to import a classification report from sklearn.matrix, and after that we are going to check our complete classification report. So as you can see here that we have a precision on not clicked, add not clicked data, that we have the 85%, and if I talk about the clicked over 96%. Accuracy wise that we have approx 90% of the accuracy. So this is the complete classification report that we are getting, where we have a precision, recall, F1 score, and complete accuracy that we have. Okay, now if I talk about the complete confusion matrix, so yes, this is the complete confusion matrix that we are getting, where this is the complete value that we have for our confusion matrix. Here as you can see here that I have mentioned the complete things. So true positive, true negative, false positive, false negative. So based upon this one, based upon the confusion matrix that we are getting our complete data, true negative, true positive, false negative, false positive. Okay, now here that I mentioned the complete description. So results of the basics model. So the results from the evaluation are confusion matrix. So the users that are predicted to click on the commercial, and the clicked user where we have 140 users. So 140 users, the people who are expected not to click on the commercials and do not click over the ads, so those people that we have 129. Now the people who are predicted to click on commercials and did not click on them are 6. So total 6 people that we have, and the users who were not expected to click on the commercials and clicked on the ads, we have a 25 people. Okay, so this is the complete confusion matrix description that we have. Now we have only few mislabeled point that we are not wrong from the given size of the data, because we have only 1000 of the data. So based upon our 1000 of the data, that we can say yes, this is the best model that we have. But as you can see here that I have mentioned, this is the basics model that we have built it. Okay, so based upon the data that we can say okay, so our model is good. But yes, going forward that we are going to do the lots of things. We are going to optimize our complete model, where we can add some of the parameters, some of the arguments, and based upon the argument that we can improve our complete accuracy. Okay, now if I talk about the classification report, so from the report obtained, the precision and the recalls are 90%. So even you can just check it out, precision and recalls are 90% that we have. Okay, now the predicted values are 90% accurate. The probability that the users can click on the commercials is 90%, which is good precision value to get the good model. So we can say this is the good model that we have based upon the confusion matrix and based upon the classification report. Now what we are going to do, now we are going to perform a little bit about the feature engineering. Then we can compare our complete precision, recall, F1 score, and the accuracy, as well as a confusion matrix report. Okay, so now we are going to apply a complete feature engineering. So first of all, that we are going to copy our data, so just to keep the original data frame unchanged. So that's why we are going to copy our data. After that, we are going to plot a complete pair plot where we are going to define here a clicked on add our target column, and apart from this one, the other variable that we are going to define like month, day, hour and weekdays. Okay, so this is a complete pair plot graph that we have. After that, as you can see again here that I have mentioned a complete description, so there don't seems to be any effect of the month, day, weekend and hour on the target variable. So yes, even that we all know, like in a EDA we have already discussed those things. Okay, so that's why I'm not going to explain this particular right now, because we have already covered this particular part, right? Now after that, what we are going to do, so if I show you again our data here, so as you can see in our data, in some of the column that we have the categorical column. So anyhow that we need to convert this particular column into the numerical format, right? Because if we are going to fit this particular data into our machine learning model, in this case our machine learning model only accept a numerical data. So first of all, whatever the categorical data that we have, we need to convert those particular categorical data into a numerical format, right? So now what I'm going to do here, so again we are going to apply a dummy encoding technique. So pd dot concatenate method that we are going to apply, because we need to concatenate with our new data frame, whatever the new data frame that we have created. And after that, we are going to apply a get dummies method over the month column as well as a weekdays column. Okay, so these two columns that we are going to do apply a complete encoding technique here, dummy encoding technique. After that, creating a bucket for our columns based upon the EDA part. So in a EDA that we have discussed, so okay, so in our hours we have a different types of the hour that we have in our data set, right? So starting from the 0 to till 24, so this is the 0 to till 24 hour that we have. So now what we are going to do, so we are going to create a complete bins in an interval that we are going to create a bins. So first bin interval that we have a 0 to 4, then 5 to 10, 11 to 16, 16 to 23 and so on. So based upon the 0 to 24 hour, we are going to create a complete bins. So 0 to 5, 6 to 11, 12 to 17 and 18 to 23. So this is the complete bins that we are going to create, a small interval bins that we are going to create. Okay, after that, here we are going to apply a complete concatenate method, and after that we are going to apply a get dummies method over our hour win column. So this is the hour win column that we have created, and based upon this one that we are going to apply a get dummies method so that we can do the encoding. Okay, now after that, again a feature engineering on the age column. So again that we are going to plot a complete bar plot against our target column. So this is the target column that we have. So if I show you here, so as you can see, whenever the people's age it will get increased, it look like the people they will click over the ad based upon this particular graph. Okay, now after that we are going to check the complete bins. So limit that we are going to set, so limit 1 18 and the limit 2 35 that we are going to set based upon the age group that we are going to set the limit. Okay, after that we are going to plot a complete count plot. So age and the hue that we are going to define our target column called clicked on add. So this is the target column that we are going to define, and after that a data frame that we are going to call. So this is the complete count plot that we are going to plot, and yes, this is the complete count plot that we have, where in a x that we have the age and in a y that we have our complete count, and the hue that we have our complete target column, where we have a two value. 0 it means no, the peoples they are not going to click over the ads. 1 it means yes, the people they are going to click over the ads. Okay, now after that we are going to create the bins on age column based upon the above plot. So based upon this particular plot that we are going to create a small bins. So 0 to 17, after that 18 to 29, 30 to 44, 44 to 69, and then whatever the data that we have. Okay, so based upon this one, like 46 to till 70, this is the bins that we are going to create. So multiple bins, young, adult, mid and elder. So these are the complete label that we are going to define based upon this particular bins. So how many bins that we are going to create? A total 5 bins that we are going to create. Total 5 bins that we are going to create. A 0 to 18, 0 to 17, 1 bin, 18 to 30, 29, second bin, and okay, 0 to 17, first bin, 18 to 29, second bin, 30 to 45, third bin, and 46 to 70. It means total 4 bins that we are going to create. Only 4 bins, not 5. It's my mistake. Okay, so total 4 bins that we are going to create, and based upon this particular 4 bins, same 4 labels that we are going to set here: young, adult, mid and elder. Okay, based upon this particular win. So 0 to 17 it means the young, 18 to 29 it means the adult, 30 to 45 it means mid, 46 to 70 it means the elder. Okay, so this is the complete bins that we are going to define here. Now after that, here we are going to plot a complete count plot based upon our age bins, whatever the age bins that we have created. Again, a target column that we are going to define as a hue. So as you can see, in a young people, a 0 to 17 year people, they are not going to click over the complete our ads. Okay, now even we did not have any types of the data age between 0 to 17. Now if I talk about the 18 to 29, so yes, in a 18 to 29, as you can see here, like only few of the people, if I talk about in a count, so look like 55 or the 60 people, they are going to click over the ads. Okay, out of we can say 230 or 240. Okay, so this is the 230 or 40 that we can see. Okay, now if I talk about the mid, so yes, in a mid, the many people, like we have more peoples, they are going to click over the our ads in a mid. Okay, so the highest value that we have in a mid as well as in a elder. Okay, so in a elder, as you can see, the lowest value, like only some of the people, they are not going to click on over the ad. So let's say we have 1,000 people. Out of 1,000 people, only I can say the 100 people, 190 people, they are not going to click over the ad. But out of 1,000, 910 people, they are going to click over the ad based upon this particular graph. Okay, now after that, what we are going to do? So now we are going to do our encoding here. So again, that I'm going to apply a pd.getDummies method over our beans column, and after that we are going to apply again pd.getDummies method over our country column. Okay, so with the help of getDummies method, we are going to convert our complete categorical data into the numerical format. Okay, after that, here we are going to remove our unnecessary features, irrelevant features. So yes, here we are going to drop a country because we are already able to convert a categorical data into the numerical format. Add topic line, a city, day, month, weekdays, hours, age, and the age means. So these are the columns that we are going to drop. Okay, so these are the final column that we are getting. So total 5 rows, and after converting, so even here we are going to apply a getDummies method, but you can try with some other method as well. Why? Because as you can see, whenever we are going to apply a getDummies method, we are getting a total 264 columns. So it will be good that you can reduce the features. Okay, now we are going to build again a logistic regression model after applying some of the feature engineering methods. So again, that we are going to divide our data into the dependent and independent features. We are going to split our complete data, and this time we are going to take 80% of the data for the training purpose and 20% of the data for the testing purpose. And after that, we are going to apply a standard scaler, so that whatever the data that we have in a different scale, that we can come up with in one scale, or we can convert all the different scale data in one scale format. Okay, now after that, this is the data that we are getting for training 800 and for the testing 200 data. Okay, now after that, we are going to apply the stats model. Okay, so here that we are going to check the complete summary of our data. So here that we are getting a OLS regression result that we are getting. So as you can see, the R square that we have a 0.89, adjusted R square that we have a 0.84, and in a below that we will get one of the summary. So as you can see here, the first note that we have, the standard error assume that the covariance matrix of the error is correctly specified. First point. Second point that we have, the smallest eigenvalue is 1.48. This might be indicate that there are a strong multi-collinearity that we have in our data. In which column? Where we have the output is 1.48. So let's check it out. So if I talk about here, so in our X4 features, look like in our X4 features here, as you can see here that we have some of the outliers, some of the multi-collinearity. So as you can see here that I mentioned, so we can see that the features number 4. So if I show you here, so the features number 4 that we have the 1, 2, 3 and 4. So features number 4 that we have the male, right? Based upon this one that I have mentioned the complete description, so we can see that the feature male gender does not contribute to the model. Okay, that is the X4. We can remove that variable from our model. After removing the variable, if the adjusted R square has not changed from the previous model, then we could conclude that features indeed was not contributing to the model. Okay, and now these are the contribution data that we have, or we can say these are the contribution features that we have, like the daily time spent on the site, daily internet usage, age, country and area. Okay, even later part that we can check the feature importance as well. Okay, so based upon this particular data, based upon this particular OLS regression result, that we are going to remove right now our male features from our data. Okay, now after that again we are going to build a logistic regression model. We are going to fit the model, and after that we are going to predict here. Now we are getting the accuracy of logistic regression on the training data is 99%, 0.99. Okay, after that we are going to apply a cross validation. So k-fold cross validation, again that we are going to define n split equal to train, supple equal to true, and after that we are going to check a cross validation score. Okay, so now on 10-fold CV, like cross validation, the accuracy that we are getting approx 0.95. So we can say the 95% of the accuracy that we are getting here. Okay, now after that again here, as you can see here, that we are going to check we are going to predict the complete cross validation model, a prediction on our model. So LR, logistic regression, X train data and Y train data, and the CV that we are going to define a 10 here. Okay, now as you can see the cross validation score of the logistic regression is 95%. So 95.6, that we can say 95% of the accuracy that we are getting. And this is a complete confusion matrix that we have, where we have a true negative value, true positive, false negative, false positive value that we are getting. Okay, now we are going to apply a random forest. So modeling with the random forest, we are going to import a random forest here, and then we are going to create a complete object for the random forest, where we are going to define some of the argument like creation, n estimator, mean sample splits, mean sample lift, max features, OBB score, random state and the AN job. So these are the some of the arguments that we are going to define in our random forest algorithms whenever we are going to create a complete object for the random forest. After that we are going to fit, and then we are going to check the complete accuracy. So first predict, and then we are going to check the accuracy. Now as you can see the accuracy wise, with the help of random forest we are getting a 99% of the accuracy. Now same thing that we are going to check the cross validation score. So now we are getting the on 10-fold CV cross validation accuracy that we are getting a 96. If I talk about the logistic regression, so in a logistic regression that we received a 95. So the little bit improvement that we have with the help of random forest. Okay, after that again here we are going to check the cross validation score. So the cross validation score for the random forest is 96.62. So this is the cross validation score that we have with respect to our random forest classifier model. Okay, now here we have our complete confusion matrix. So you can just check it out, this particular value here that we have the 14, 11. So and as you can see here that we have the 24 and the 15. So little bit differences that we have in our confusion matrix. Okay, even you can check it out the complete value like the true negative, true positive, false negative and the false positive value. Okay, after that here we are going to check the feature importance. So again we are going to call the columns, and after that we are going to create a complete data frame. So converting the numpy array list into the data frame. So we are going to create a complete data frame. After that we are checking our complete feature importance. So here pd.data frame we are going to define a random forest dot feature importance, index on the train data, and then importance that we are going to call. So as you can see here, if I talk about the contribution by, so yes, a daily internet usage, this is the most important feature that we have. After that daily spend on site, then area income. If I talk about the top 5, so till top 5, as you can see the till top 5, the age adult and the age elder. So these are the some of the important feature that we have. The less contribution feature that we have, the country, our male. So these are the less contribution features that we have in our model. Same way here that I have created a complete graph. So even you can check it out the complete graph as well. So daily internet usage is the most important feature that we have, and the less important feature that we have, a country, Australia. Okay, now after that we are going to test a complete model performance. So yes, this is the complete model performance based upon the ROC and AUC score. So yes, classification report based upon our random forest and the logistic regression that we are getting. So this is for the logistic regression, and this is for the random forest that we are getting. So as you can see, in a logistic regression AOC that we are getting a 91, and in a random forest that we are getting a 94. Now we can observe a random forest has the higher accuracy compared to a logistic regression model in both training as well as in a test. Okay, so that's why we are going to select a random forest model here. Okay, now after that what we are going to do, so here we are going to do some of the prediction here. So final prediction, again that we are going to do some of the prediction here. Okay, so fit the model on the entire data and save the prediction on a CSV file. Okay, so here that we can save the complete CSV file, and after that I'm going to plot here ROC graph here. So this is the complete ROC graph that I have selected. Again, as you can see here, a random forest classifier area is 94%. This is the big area that we are going to cover with the help of random forest. So definitely a random forest is the best model that we have. So what we can do here, we can select a random forest model, and based upon this particular random forest model, then if you want, you can build a complete web application with the help of HTML, CSS, and for the API calling that you can use a Flask. Else what you can do, you can use a Streamlit, and with the help of a Streamlit you can build a complete web application for this particular project. Okay, so yes guys, this is all about in this particular project. We have started with the problem statement. After that we do the sum of the EDA, we find out lots of insights from our data. After that we apply the feature engineering, and then we build a complete model with the help of 2 machine learning algorithms. And after that we come up with, okay, so the random forest classifier, this is the best model that we are getting, and from this particular model that we can put it down this particular model to a final production whenever we want to build a complete web application. Okay, so yes guys, this is all about this particular project. Make sure you can like the video, subscribe the channel, and share with your friends, and please make sure whatever the issue, whatever the error that you are getting, or whatever the query that you have with respect to this particular project, write it down in a comment section. See you in our upcoming project. Thank you.